So, first of all, thanks to the course lab who came to the staff student liaison meeting yesterday, and we presented your course. And out of, I think, 7 or 8 the course labs that should have been there, you were lucky enough that your course lab was the only one who actually turned up. So, yeah. Okay. The other thing is, I mentioned it in the first week of this module. You notice that we are not always in the same computer room, and that is because facilities management, no, I should say central timetabling, had problems finding computer rooms for us. That's why sometimes we are in different computer rooms. And I mentioned in the first week, there's 1 week where they said they can't find a room at all, and that's this week. You might have seen it on your timetable. If you check your online timetable, it doesn't mention a room. So basically, officially, all the computer rooms at UConn are fully booked today. I wouldn't be surprised if there's a discrepancy between what the system says and the reality. But nevertheless, even if there is an empty room somewhere, we don't know which one it is. So no computer room today. But the task today, we'll just move on from what we did last week. So that will be quite easy. Last week we talked about colors. Today I want to talk about image formats, bless you. And we can then basically try to put images into our files. You can do that from home if you like. I'll be available if you want to call my number or come to my office, or I'll send me an email, or you can also leave any questions for next week. But there was no computer room available for this week. Another thing is one of your classmates said, all of the modules he has similar content to what he's done in previous years. Now, obviously, you're from different courses, you've done different modules in the past, so this will not apply to all of you. But to address that, I shuffled the content around a bit. So after we finished with image formats, instead of explaining the background of CMS more, I want to talk about CMS first. And we haven't done databases and so on yet. But once we talked about CMS, if you want, you can start working on your first assignment, the report. So after the image, I'll talk about what CMS can do. I think we've all got a good enough understanding of the web by now, so that the CMS makes kind of sense for us. So we talk about CMS, and then next week, the week after, I'll give you the assignment brief. Now the deadline is February, or whatever it says in the MIP. I forgot the exact date. It's far away. It's in February. But I'll give you some first class assignments from the previous year, so that you have a rough idea what I'm after. But because I move this forward, I hope the ones who've done similar stuff in the past won't get too bored, because you can focus your energy on working on the report early if you want. Obviously, the deadline is unchanged. I just basically cover this a bit earlier. It gives you more flexibility in working on the assignment early if that fits your personal timetable. We all have a different type of modules here. IB students have, depending on their background, have 2 or 3 compulsory modules. So there's these options, and there's some marketing students here. You're marketing? No, wait. The marketing people normally sit here, but no. Are you marketing?
Yeah.
Yeah. You're the only marketing student today. So I don't know whether all the marketing students have the same kind of modules. But the IB students, everybody has different modules. So if you've done this kind of stuff before, it gives you the chance of working ahead. Okay, so let's do a quick recap of last week, very quick. We talked about binary and hexadecimal numbers. They are the numbers we are normally not used to. And we talked about, can you see? As best we can do at the moment. Oh, there was that. Does this scarf belong to anyone? See whether we can use the scarf. I would not. Well, I don't dare to climb on the chair. On the other hand, I have lots of witnesses for my claim if I fall off. So, are you taller than me? Are you taller? Lift your hand. You're taller than me, aren't you? A bit. Can you put the scarf there now? Not much taller, I think. We want. Wait, there used to be a stick. Some rooms have a stick for the silver screen.
How about you stand on this chair? And
Yeah,
I can hold this for you.
Oh, okay.
Hold the chair for you.
Thank you.
Okay,
let's do that. Well, let's work.
Perfect.
And you're only pretending you're holding the chair, aren't you?
Yeah.
Yay!
Wait,
That worked.
be careful. Okay.
Thank you. That was very good teamwork. Only a tiny bit of the screen now lit up. Okay, so we talked about the colors. So it works the opposite as the watercolors on paper, yeah? Because we talked about it, paper reflects the light from another source. So on a sheet of paper, imagine this is a sheet of paper, no color, white. Whereas here, we are emitting light. So no color is black. So we decide that green and blue, we give it values. So hexadecimal, the highest symbol in quotes we have is F. So we have 256 values for that, 256 values for green, 256 values for blue. And that gives us a color, or a shade of color, out of 16.8 million colors. We can use it here, we can set a background color, or last week you set a text color. And the next point what we wanted to do is we wanted to talk about image formats. So, I think we started talking about GIF, or officially it's supposed to be pronounced GIF. A look. Okay. So how does a GIF work? Yeah, very simple example. Let's say we have 5 pixels times 5 pixels. So we are all clear that images contain pixels, yeah? Okay, there are two kinds of images. The raster image, they contain pixels. If you watch telly, you might have heard 4K. That's a reference to roughly how many pixels there are on the horizontal axis. Or you might have heard 1080p. That's a reference to how many pixels there are on the vertical axis. There are also other ways of describing images. Yeah, you can, for example, mathematically describe the shape of an image. That's used for fonts, for example. Yeah, that means if you have a font and you print the letter E, you can print it tiny. You can print it on an A3 printer. Yeah, it takes up the whole space of the A3 page, and you could take a magnifying glass and it would still look fairly round. Yeah. So you can basically zoom in as much as you want, because a font, for example, does not contain pixels. A font, or most fonts we use these days, is basically a mathematical description of the form, which means you can zoom in as much as you want and you won't see pixels. But the image we normally use on the web, they do contain pixels. And that is also causing some sort of problems for us. Because the web, yeah, let's talk about it again. When did the web come about? The World Wide Web. The internet was in the 60s and the web was in the 90s. Okay, so in the 90s, obviously, computers weren't nearly as good as they are today. Specifically, what I'm referring to is what started maybe 5-6 years ago or so. Anybody here who's been using iPhones for a long time? Yeah. So there was a point, and I forgot when it was, when basically the iPhone was the first device to switch to this high resolution display. Did they call it retina display? When was that? Was it 5-6 years ago? Or longer? You know, the old iPhone had a normal kind of display like every other phone. The first iPads were like that. And then Apple started basically increasing the amount of pixels per square centimeter massively. Yeah? 4 years ago, do you think? 4, 5, 6? I don't know. I think the iPhone is 10 years old, so I don't know. It happened a few years ago. And then everybody else, actually it was more than 4 years ago. Anyway, and everybody else followed suit, and now the other manufacturers have even higher pixel density. But that was basically the point where our traditional way of displaying images on web pages didn't work anymore. Why? Because we used to assume a user has a certain width of pixels for the screen, and that's for argument's sake, we assume the width of the screen is 1,000 pixels wide. And then if we thought something like this picture should take roughly half of the screen in width, we would say this picture should be 500 pixels wide. Now obviously that stopped working, because suddenly our devices can fit a much higher pixel density in. So suddenly, whereas in the past 500 pixels was, let's say, half your screen, suddenly 500 pixels is maybe only 15% of your screen. So that whole system of describing a web page by using pixels broke, and we still haven't properly fixed it. There are lots of workarounds at the moment. So what we do at the moment is, for example, on our web page, we can upload a normal pixel-sized image, and we can upload a high-definition image. Yeah? And we then run some little code that will basically figure out whether our device has a high pixel density or not, and it will basically display the high definition image if our device has a high pixel density, or a low resolution image if we have a low pixel density. Is that a MacBook Air? Oh, yeah, okay. So Pro, for example, high pixel density. Yours is a Pro? Yeah. Anybody with a MacBook Air? You got a MacBook Air? MacBook Air, except the one that came out last week or whenever it was, still has the old pixel density. Yeah. So let's say if you were to look at the same web page on a MacBook Pro and a MacBook Air, there would be differences. For example, if we don't provide a separate high definition image, it would look very pixely on a Pro. Yeah. The same is true, this is not only an Apple thing, the same thing is true for Android phones, the same thing is true for Windows machines. They also obviously have high pixel densities now. So we kind of broke the system, and there are workarounds. Like I say, we run certain code, we put certain extensions into our web page that will basically try to figure out, does the user have a high resolution display, and if they have it, we kind of swap the images around. Now I wanted to make you aware of this, but for now I'm gonna ignore this. We just pretend, a picture has certain pixels, and we just look at it as it is. And actually the reality is got a bit more complicated 5-6 years ago. But you're not here to study web design or anything like that. So it's good enough that you are aware of the situation, and we look at the simplified version at the moment. So imagine this is my picture. It's a shame there's no filling function here. So let's say, can I make this wider? Imagine this is my picture, so I can fill out the pixels now. I'm not doing it very well. But I could. This is supposed to be some sort of cross. Maybe a little picture I used in a questionnaire where there's a tick or a cross. So, but this is basically how it would look like. We have certain pixels, obviously very much zoomed in now. A picture could have 1,000 pixels. Now, how does it work in a GIF, or should I say in a GIF image? Basically, we define a palette. So if we have two colors, we can say the first color is, and computers tend to start counting with 0 because of the binary system. So first color is some shade of red. First color looks like this. Second color, third color, fourth color. So in my example now, I work with 4 colors. Some sort of pink, some sort of purple, some sort of white. This is supposed to be white, some sort of black. So every single pixel now, I basically just need to use 2 bits to represent every pixel. So in this case, this pixel is color 01. This is color 10. So 01, 10, 10, 10, 01, 01, 10, 01, and so on. So basically, if we were to look into the files stored on our hard disk, I can basically count the zeros and ones, and they would kind of represent that pattern. So we can see here, the more colors I use, the bigger the file will be. At the moment, I use 4 colors, I need 2 bits. If I wanted to use 8 colors, I'm gonna need 3 bits. So suddenly, doubling the colors will make my file 50% bigger, because I'll need 3 bits next. Doubling again, file again 50, not 50% bigger than here, but 1 bit more for every pixel next time. So the more colors I use, the bigger the file is, but the maximum is always going to be 256. The other interesting thing here with GIF is we can do animations. You might have seen little animated GIFs of cats playing piano or whatever it might be. And we can have a transparent color. So pictures usually are always squarey, but whatever we want to show in the picture might not be squarey. Might be a bowl of noodles. The bowl of noodles would not have a squarey corner, would have some sort of jagged round corner. So we could basically define a background color. We could say, this is no color, and if we then put the picture of this pot of noodles in front of a background, then instead of seeing a squarey border, we would see the border around the actual image. So GIF, quite good. We can do animations, we can have a transparent background, but we only have 256 colors, including all shades of color. So not very useful, for example, for pictures, let's say, of a person's face with lots of different skin colors. Or a picture of the white wall, it would already be not that great, because there'll be lots of different shades of gray here. Some dark spots, some white spots, some dark areas. Each different shade of a color would take away a whole color, and we only have 256. Next approach, JPEG. JPEG has the advantage that we can make pictures much smaller than they should be, because we compress the image. There are two types of compression. Let's start a new page. So there's lossless compression and there's lossy compression. So lossless compression is a zip file. Do we all know what a zip file is? What's a zip file?
Zip file. Sorry, I don't know that.
You know? No.
No.
Who knows what a zip file is? You know? Yeah? So give me so let's say you write a dissertation. And the dissertation is 2 megabyte big. You can zip it up. It will be much smaller. Suddenly, instead of 2 megabytes, it's only 500 kilobytes. So you can send the file to somebody, they can unzip it, and they get the original file back. You can make a file smaller. How does it work? I'm completely oversimplifying things, but let's say you wrote the dissertation in English, and again I'm completely oversimplifying, but let's say that appears very often. So instead of always writing that 100 times, we can replace it with something shorter. So we're basically replacing bits that repeat with shorter sequences, and we basically make a note, oh, this repeats very often, let's use something else instead. So the more repetition there is in the file, the smaller you can make it. It is lossless, which means when you unzip, you get exactly the same file again. When you zip up your dissertation to send it somewhere to your friend to print or whatever, and when he unzips it or she unzips it, you want the file to be the same. It's not good enough if you say, oh, the letter A and the letter, I don't know, the letter D and the letter B look quite similar. Let's save some space by only keeping one of them. That wouldn't be any good in your dissertation. Whereas lossy compression kind of works like that. We might think, oh, the letter L and the letter I work similar. Let's make them all the same. We save a lot of space by doing that. Lossy compression, we actually lose information. But we try to lose information that is not noticeable. Who's listening to music CDs? Music CDs, very old-fashioned. You do. Okay. How many minutes fit on a music CD?
Generally under hour.
Okay. So how many? You can also use a CD and you can write data onto it. How many megabytes fit on a CD? Anyone have a guess?
2 minutes.
2 megabytes? Okay. So one of the original standards was roughly like this, 74 megabytes, and let's keep it simple. 74 minutes, 740 megabytes. So 1 minute of audio CD. How many megabytes? 10. How long is your average song?
4 minutes.
4 minutes, so a song is 40 megabytes, is that right? Who's listening to MP3s? You ever listen to MP3s? You have? Okay, how long is a song? Okay, 4 minutes in audio length. How big is the file in megabytes?
Basically 10.
10? Yeah. Okay, yeah. You know, I mean, there'll be different compression rates. 10, yeah. If you do something like 128 kilobits per second, which is still a good quality, you'd probably even end up with something like 4 megabytes per song. So 10 times smaller. Does it sound as good? Music CD and MP3 file? Similar. Why is it so much smaller? We got rid of all the things that the system thinks the human ear can't hear anyway. Yeah. Example is a lorry drives by and you drop a needle. Yeah, the sound of the needle dropping is in the room, but we can't hear it because the lorry dropped by at the same time. There'll be certain frequencies if they play at the same time, the human ear can't hear it. But basically, we remove information, and we remove lots of information. We only have a tenth left in the end, but we remove the information that we normally can't spot. Dogs, I think dogs are supposed to hear better. They see worse, but they hear better than humans. Is that right? So maybe, you know, if you have a dog, your dog can probably hear the difference between an MP3 and a music CD, but we probably can't. Anybody into photography? Anybody here with a SLR? No one? Okay. Similar compression mechanisms. Yeah. If you take a raw photo that is uncompressed, it's maybe roughly 10 times bigger than a JPEG would be. So JPEG again, you know, we have a picture, we split it into little pixels. And basically, instead of recording the color every time, again I'm simplifying, like they did in GIF, we basically record the color, and next pixel, instead of recording the color from scratch, we basically say, how is this color different to the color before? Is it a bit lighter? Is it a bit darker? Is it a bit more blue? Is it a bit more red? So we can save a lot of data by basically describing a color based on the color before. Yeah, I'm simplifying, but roughly that's the gist of it. Now with JPEG we can compress more, we can compress less. But while something like GIF or GIF is suitable for, let's say, a pie chart or a bar diagram or something like that, JPEG isn't necessarily. Because, you know, if we've got hard color differences next to each other, JPEG often can't handle it. Yeah? Because in the end, we're describing the picture based on the color before, and we can only jump so much. If the difference between two colors is too big, that kind of gets lost. Let's do an example. Oops. Oh, come on. Let's go to a website. Okay, here we are. I take a screenshot now. Okay. Now I'll start GIMP. Yeah, what's this? Ah, you didn't see I took a screenshot because I've got two screens now. Okay, anyway, just you've got to believe me, I just took a screenshot of the UCLAN web page. Okay, new Okay, here we are. Paste. Well, this is, yeah, because there are two screens. It basically, let's try again. Let's do it much bigger. I don't know, 5,000. Can I do 5,000 times 3,000? Let's try that. Paste. Okay, here we are. So yeah, because there are two screens, it's quite big. And notice something else. This screen has much more pixels than this screen. Is this obvious? Yeah, because it's much wider than this one. Even though actually this was that screen and this was this screen, which is centimeter-wise much smaller, but this is a high pixel display and this isn't. That's what I was talking about earlier. Yeah. So even though physically this screen is much bigger, it has much fewer pixels because this is a high PPI display. Okay, so here's my picture. I'm gonna save it now as a JPEG. JPEG. And to make it very obvious, I use a very poor compression. Yeah. So the more we compress, the smaller the file's gonna be. So I'm gonna use a tiny file size, which results in very poor quality. Let's do the same thing again in a good quality. Let's see what the difference is. Export. Okay, let's do the same thing in good quality. Okay. Documents. Here we are. So, one of them is 200 kilobytes, the other one is 2,500 kilobytes. Yeah. So this will be the good quality. Let's have a look. Yeah. Let's zoom in. Yeah. Looks quite good. Let's open the bad quality. That's much smaller. And you can already see now that something went wrong. Look how poor the colors are being rendered here. Yeah. Look how look how poor it looks here. I'll zoom in a bit more, otherwise maybe if you're in the last row you can't see well. Yeah. This is not gray and black. You know, this is like all sorts of colors jumbled up here. Yeah. So this is the problem with JPEG. Obviously, I was using an extremely poor compression here to make the point a bit stronger. But even though it might look okay on your machine, somebody with a better screen and or better eyes might see problems with the image you can't see. Anybody used Windows 95?
Long time ago.
Long time ago, there used to be that background picture of a green field, which has been turned into a vineyard by now. I read once. And at the time, 95, this looked good on our cathode ray tube monitors. But if you see that image now on a high quality, flat screen monitor, it looks awful. You can actually see all the compression artifacts. Okay. Then there's one more to go. So there's GIF or GIF. Come on. There's JPEG. And there's PNG. Came around much later, but still somehow is not that popular yet. You'll still mainly find JPEG pictures on the web. It can do lossless and lossy. Yeah. Lossy can make your files a bit smaller. Lossless can still compress it like a zip file, but you don't lose quality. And it has another advantage. No GIF, we can have a clear pixel, a transparent pixel. PNG has a 8-bit alpha channel. 8-bit, so 2 to the power of 856. So basically, we have 256 different levels of transparency. So for argument's sake, you have a photo of a car that you want to use on your website. You could make around the car transparent, and the windows of the car you could make half transparent. So whatever the background is on your website would shine half through the windows. So, and in fact, we have 256 levels of transparency we can apply to the picture. Okay. So last week you colored text, so this week, now unfortunately no computer book for us, but please install GIMP. You can also use Photoshop, but Photoshop is quite expensive, so I suggest if you get used to a software anyway, use GIMP. And we can then resize images however we want, and you're gonna need that when you create your content management system. Okay, so we did that, and let's have a quick look at content management systems now. Oh, I'll delete those before I forget. So here we are. Okay. So, just a quick reminder. So, in the beginning, we had static web page. Yeah. So, you create a web page. It's based on HTML. You write a web page that says the weather is sunny today. If you go to your web page in 5 years' time, or in another season, it will still say the weather is sunny today, even though that's obviously not necessarily the case. We then had dynamic websites. We talk about them in the future. But this is basically websites that mix programming code into the HTML code. So we could, for example, in our website, we could talk to the BBC Weather API, and we could basically ask BBC or Yahoo, how's the weather today? And we could then basically display this information as part of our website. Yeah. So first we had static websites. They're a bit like a printout, they never change. Then we mixed in programming code. And companies who wanted websites, they would base their websites on these technologies. But in the end, all the companies, they want a similar type of website. Yeah. We usually have the logo in the corner, we got a menu on the side or at the top. Websites, usually they all work the same. Some websites will be different if you have very special requirements. Let's say, especially if you sell online, you might have a thing that sets you apart. So let's say Amazon will have an unusual website in a sense that they have to program it themselves. But you know, if you're the local pub who needs a website, or if you're a local manufacturer of paint, or whatever you might do, your website would often look the same. You would just want to present yourself to the world so that they know that you exist. And you know, if you don't have a website, they might think you're a bit dodgy. I mean, even if you have a website, you might be dodgy. But if you don't have one, that would probably look suspicious to some of your potential customers. So the idea here is, if most of us want the same kind of website for our organization, why do we have to start from scratch every time? And this is where CMS comes in. The system we just put on our web server, it's based on dynamic website technology, and it helps us to organize and control our content and to publish it. Most CMS, there will be some exceptions, like the first CMS you're going to look at, But most CMS will be built for many content contributors, which means what does our company do? Let's give an example. Or our organization could be a charity, it doesn't need to be a company. Want to pick an example? Car sales. So we are selling cars, yeah, and we are local. So we don't really, we have a shop in Chorley or I don't know where. We don't really expect people to go to our website and buy that car with their credit card on our website. So good example, because we use it to represent what we do. We don't actually do business. But we could, for example, so which brands do we sell? Between two brands? Mercedes and BMW. Okay. So let's say you are the Mercedes guy in the company and you're the BMW guy, yeah, and you get commission. So you don't like each other. Every time a Mercedes is being sold, you can like each other in reality. Every time a Mercedes is sold, you get money. Every time a BMW is sold, you get money. Yeah. You want to split access to the website. You're the one who puts the Mercedes cars online. Yeah, you got a new 5-year-old baby blue Italian Mercedes model. C-Class, yeah? And you want to put it online. You don't want him to have access because he's gonna like naughty things so that people buy his BMWs. Yeah? You're not gonna, I know you're the kind guy. I'm just pretending. Okay, so we can distribute the tasks. We can limit access, and that's the whole point here. We can have many different content contributors who have different permissions. You have full permission in the BMW part. You get a new BMW model, cheap, not cheap is that. A new BMW 4x4, you want to put it online, but he should have access. So we can have many content contributors with different levels of access. You might have an apprentice. The apprentice can put the stuff into the system, but the apprentice might not be good enough that you trust them. They might do spelling mistakes, or they might put the wrong price up, and suddenly you've got to sell the car for 50 quid because the apprentice made a mistake, and you've got to honor your promise. So you can, for example, say the apprentice can put stuff in, but it doesn't go live until somebody with higher authority approved it. So that's quite good, and we can change stuff through a web interface. Yeah, we don't need specialist software. When you install the CMS, you need specialist software once when you install it, the CMS. We're going to use FileZilla to send it to the server. But once it's installed, the system will provide us a web interface where we can basically create our articles and modify things. And we can put in all sorts of content, text, image, audio files, links to videos, and so on. We can automate things. Yeah. Do car shops have Black Friday sales?
They have sales.
They have sales. Okay, yeah. Let's say we've got a sale at the moment going on for 5 days. You can set it up that there's a big article and a landing page that says, 5 days only, take 5% off your car price. Yeah. And you can set it up that this article, this big advertising on the landing page will automatically go away after 5 days. We can have extensions, we can have basically mechanisms built in that, for example, the car you entered, we can press a button and it will become a PDF that you can print and put in the, put the tag on the car window, or the potential customer can print so that they can compare things. We upload a picture, we might want a thumbnail. What's a thumbnail other than those? Have a guess? What's a thumbnail? Did you do web stuff on marketing?
No.
No. So any idea what a thumbnail might be?
Is to like an attachment.
Yeah, okay. I didn't know, it could be that you did that stuff before. Now a thumbnail is like a little picture. Yeah. So let's say the picture you took with your camera of the car might be 5,000 pixels times 5,000 pixels. We might not want the full picture in the article, so the system can automatically create a smaller version of the picture for us, for the article. But we still, is it a real alarm?
Yeah.
I thought a test on Thursday. Sorry, I don't want you to burn to death. Let's go out then, if this is a real one. I thought it's a test.